Hello everyone, I'm Xiao Gang. In this lesson, we'll start writing this response. It's actually quite similar to what we did before, but it's pretty complicated. You can see we've written 150 lines of this response, and it's still not code, and we've probably written about 100 or 200 lines of this response already. No way around it. Now, we need to do another integration. Let me explain why we're doing this integration. First of all, let's raise the log level a bit. We'll still release it at the very end. Then first, we need to check if this HTTP has a while away. So let's first send out this HTTP request. Let's write the error handling first, because this error is easier to write. If it has this network issue, then we first prepare a network issue error response. That's it. We can call it error message or error info. Okay, so first we need to determine that we still need to prepare a response message. See here, prepare this, because we need to assign and pass it out. And this value here must be assigned beforehand. It has a be request stream. This part is required info that's point you. This value is passed through here. It is passed from this place because this value is passed because when you search it on Baidu, actually, we don't know whether what it sent back is the loss. We can only control whether what we requested is this loss. And then because in this situation, actually, we are not quite sure what exactly went wrong with it. We'll just print it out here. That is just printed out directly. That is, this HTTP failed. Then we take this, we get this information and give it to him. Just output it as JSON. And at the same time, we pass this out. Quan fail, right? Quan fail means we failed. Then we just pass this information along. So here, you can also retrieve the status code or something, but this kind of issue is usually a network problem because it simply didn't receive the response from Baidu. So we handle this kind of problem like this. Next, we need to make a distinction. That is, we need to make a distinction here because the writing for streaming and non-streaming is different. If it is streaming, we will leave it for now. For streaming, we will leave it blank here for now because streaming is more complex. So let's write the non-streaming one first. If it is non-elect, then through hierarchical reading method, we complete such an operation. First, we create a hierarchical object. After creating the hierarchical object, we create a read stream. For this read stream, we read this hierarchy, the response hierarchy. Then after reading it out, we deserialize the jelly identified. This is a read stream. This is an object. Read the content from the stream into this object. If the deserialization here fails, then it proves there is an issue with this connection. If it proves there is an issue with this connection, then we need to log it. That means our parsing of the connection failed. Then what is the connection that failed to parse? We also need to output it, record it. We can just let it idle and discard it. Then here, displays this information. Okay. Of course, this information, actually we need to do this as well. Also need to do this. This way we can know in advance. But actually, you have already failed. In that case, you won't really care whether it has elapsed or not. Okay, so if it succeeds, only then will we parse the data inside. So, let's first check this place. I'll finish writing this part first. Let me explain to everyone again why we wrote it this way. That is to say, we first check if he has this field or this field. If this field exists, it means there is an error. Why do you say we don't use this struct here? We do use a struct, but when you use it, you have no way to determine. You need to check whether the current one is an error. Because the error is this kind of information, you will find it is different from ifly-tech. It does not have the concept of primary and secondary services. If it is an error, it will directly give you this. If it succeeds, what it gives you this thing. So these two things, you need to judge them first. Only then will you know if it is a struct. Right. So here we first make a judgment. So I use this read stream here to read whether this thing exists. If there is an error, it means an error has occurred here. We just need to read the error code. This part is a bit tricky. There are many nested layers. So let's first prepare an incorrect message info. Because at this point, it's just this. We'll call it error info, or we could call it error message. That's fine. We'll call it error info. Okay, since we know it's already an error, we'll just directly convert the response JSON over. Okay, after converting it, we'll then construct our HTTP error. Actually, at this point, it's not an error, it's just a response info, because this is the information provided by Baidu. So let's put this churn and non-churn. Here for, okay. Actually, this thing can be placed on this outer layer. Placing it on the outer layer is also fine. Then you won't need to declare it here every time. But since we have the bubble protection here, let's still declare it. First of all, this result is definitely of type Spire, and its error message is the information read from the error code in this struct. Then we need to copy this error info to the error message field. Then we also copy its original data. Okay, should we make sure we don't miss any data here? So it's written this complexly. Then let's print this log again, because at this point, our non-streaming type failed. It will report the reason. The error code 14 we reported earlier means validation failed. That reason will be reported right here. Okay, at this point, we transmit the information out again. Then in this non-streaming case, receiving an error response from Baidu, this part is resolved like this. If this is not found, it proves it is a normal non-streaming piece of data. So we need to prepare a non-streaming data to receive it. So we use this struct. We call it FBdNonStreamFinalMessage. Because it only has one final message, then we use the convert of the receiving object to perform such a header conversion. After the conversion is complete, we now start to fill in our header info. First, we just copy this field directly. We get this header from the HTTP response. And this header means whether this field exists. If this field is not empty, we put this thing in the header info. Just copy it over, because it's just a request limit field. Note that sometimes a null pointer error may occur here. The reason for the null pointer error is that your URL is written incorrectly. That is, your URL cannot be resolved into data accessible over the network. Therefore, the response here becomes a null pointer for this reason. Generally, this kind of problem does not occur, but it can happen on the machine. That is, your URL is written incorrectly. Finally, if a null pointer appears, just handle it like this. Handle it. Yes, sometimes it's passed from Blueprint, or you wrote a general interface for it, but the URL passed from Blueprint was written incorrectly. An extra space or an extra symbol, something like that. Then we haven't made a judgment here. These two things are null pointers. Under normal circumstances, they won't be null pointers. Okay. Then later on this side, I copied it over. Nothing much to say about this. This part is in its header. There will be several fields in getHeader, but these several fields might be from before. Maybe now. We'll just ignore it. Whether to write this thing or not actually doesn't affect our thing much. Okay, so now that we've written it, we need to start preparing this response, this info. So for this response info, then here we copy this non-streaming data onto it. That is the data we parsed. See, it's this, right? This is the data. After parsing is complete, we change this result to true because this is successful. Then we take this messages, copy it over here. You can see here, there is a result, this message, and here is the original parsing. So this result corresponds to here. We can see it is this. Just copy this value in. Then our message can be used directly, just these three brothers. This is the main field we use. Okay, after finishing that, we can directly call on success. Good. So this way we have completed our parsing of this non-streaming data. Okay, now let me summarize for everyone. This part is very long and very complex. We should write it as a method, but we didn't write it that way because writing a method might require writing this again. Things like header files are more troublesome. We'll just write it all in one function. First, after entering, we print out what the data actually is. Then we check whether this itself is normal. If it is not normal, then we direct take this down. We'll just right here, Tell everyone it's a network error. Your network connection is wrong. Okay, if it is normal, we determine whether it is streaming or non-streaming. Okay, this part is determined by our requested data. Then, after the judgment is complete, we haven't written the churn yet. The churn is in this place. The churn is relatively complex. We will write it soon after. So, if it is non-churn, we first check if there is an error code. If there is an error code, that is, if there is an error code, we can directly return an error message. Then in this place, we check in this place, we first need to parse the token to ensure that the token is valid. If the token is invalid, we return a token error. If there is an error code, we extract the error code and then return this error code to the user. Then if the stage verification is also correct and there is no error code, then it proves that this is a normal final data. Then we take this final data and pass it back to return it. Okay, let's start testing now. Okay, we have opened it here, and for this test, let's keep it simple. We'll just print it out. As for the rest, everyone can play around with it on their own. It's just a large language model. We press 1. Okay, it should have returned, but it seems we haven't seen it here, right? Here it shows that we have already received this information, but it seems it hasn't printed again. Let's check. Let's see if this pin hasn't been called. Let's take a look. It should need to reach this point. Let's set a breakpoint. Set a pipe, and let's check. Execute it. Okay, it entered. And the part before this should definitely be fine. Let's take a look. Okay, it should be fine too. Virtual dragging successful. Hey, it has no errors, right? It should be. This path is very simple. We definitely didn't write it. We absolutely definitely did not write it. We forgot to write this. Okay, no problem. Let's plug it in. This is also very normal. This should be from when we started. Forgot to write it. We just need to plug it in, so it's not being called. Set a breakpoint. Sometime you understand then. Here, let's put the 3 pins here. We can just let it execute in one step. We put it in the update. Update. At this point, we execute it again. Then we can see the blueprint receiving the response data. Now let's test it again. Test it. You see, it's a bit slow. It's already in here. Then we remove this breakpoint. You can see, it is already printing the information we need on the blueprint. We can click it again. Okay. No problem. We have completed the non-churn interaction here. Okay, let's end this lesson here. Okay, thank you, everyone. Wait a moment, we can set a breakpoint for everyone. Let's take a look. Let's check if this information actually exists. Let's take a look. We'll wait for him to come in. Okay, we're mainly stopping here. Let's check his response section to see if there is any header information. You'll find that it does exist, right? Let's take a look at this response. You can check it out if you're interested. We can see it. It is actually read it out. This token information, you can see, it clearly has this field, proving there's no problem. Okay. That's all for now.